Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to talk about congruent and also similar figures. So let's get started. Congruent figures. Congruent figures have exactly the same size and same shape. The symbol we use is for congruent is what's on the screen. It's an equal sign with a tilde on top of it. And so that is our symbol for congruent right here. Corresponding parts of congruent triangles are equal. What do I mean by that? The sides that lies opposite equal angles are corresponding sides. The angles that lies opposite equal sides are corresponding angles. So let's look at some examples of what we mean by congruent. Here's an example. We have two triangles, A, B, C, and then the one on the right is D, E, F. They're congruent. How do we know that? Let's determine the congruent equal sides. In this case, we look at this. Side AB, notice how we write it, side AB and DE lies opposite of the angle 62 because all of them both triangles have the same three angles, 62, 80, and 38. Therefore, AB is equal to DE. We see similarly that BC and EF lies opposite to the angle 38 degrees. Therefore, BC is equal to the side EF. And then again, the last thing is AC and DF both lie opposite of 80 degrees. Look on our figure here, opposite of 80 degrees. Here's 80 degrees. And we have the opposite AC and also side DF. Therefore, AC is equal to DF. Again, we're looking at congruent figures in this case. Congruent figures refer to the triangle below. So this is our example. We have triangle MNP and triangle RST. Are congruent. Determine the congruent angles that are equal. In this case, we can see the sides. We're going to look at the sides. And since we have 2.6 on both of them, that means angle M and angle R are equal because it's opposite to 2.6. Similarly, we're going to look at the same thing with the other two sides. We look at the 2.1, and therefore we'll look at N and S, or excuse me, in this case, we have the angle N, and I believe it's the angle S that we're looking at this being equal. So let's make sure we have this correct. So this should be S according to our diagram, not P. And then also look at angle P and angle T, they're equal because of the 1.8. So make sure you note the correction there. Now, similar figures, let's talk about that. Similar figures means, and this is important, that they are like in shape, but different in their size. So they're like in shape, but different in their size. So give me an example. So here's a triangle, and then a similar figure to look like this. The shape are alike, but the size are different. The size of it are different. So that's what we mean by similar. Let's keep that in mind. and in similar polygons have the same number of sides, equals corresponding angles, and proportional corresponding sides. And the key to this is the angles are equal angles, but their sides are proportion. Now, this doesn't mean that they're equal. So we got to have the equal angles. Now, the symbol we use for similar is this. So we could draw that, and that's our symbol for similar. Again, what's important is angles are equal, but the sides are proportional. The distance around a parameter, or excuse me, we usually call it a polygon, or the sum of all the sides is called the parameter. So the parameter, so if you have a triangle, add up all three of the sides, that is your parameter or your perimeter, some would call that. And two polygons have equal corresponding angles. It does not necessarily follow that the corresponding sides are proportional. So I want to look at some things here to understand what we're looking at. Let's look at these similar figures. Why are they similar? Because the shapes are the same, but the sides are different. We have A, B, C, D, E, F, and then we have A prime, B prime, C prime, D prime, E prime, and F prime. The prime one is one shape, and then we have the other one is the other. So we have a shape on the right and a shape on the left. Now let's look at this. The corresponding angles are equal. So angle A should equal angle A prime, as if these are similar figures. And I'm going to give you that symbol again. Here's our symbol for similar figures. So if they're similar, we're saying that this is similar, then angle B equals angle B prime, angle C equals angle C prime, and so forth and so forth. Also, the sides are proportion. And you may want to write this down, that AB divided by A prime, B prime has the same proportion as BC divided by B prime, C prime, and again, going so forth and so forth. So we should put equal signs here to say that if we divide one by the other prime one, it will always be the same proportion. So let's look at an example. Let's do one right now. So given the similar polygons shown below, given we have A, B, C, D, E, F, similar to what we did earlier, and we have the A prime, B prime, C prime, D prime, E prime, and F prime. And it says if AB, and in this one, I'm not going to do it on my whiteboard. I'm going to leave it on this. So if AB right here is 9.1 centimeters, and also A prime, B prime is 10.5. Again, they're not the same. The shape's the same, but our sides are proportional. We'll look at that. And we know that EF, this is right there. EF is right here. I'm going to make the line. EF is 5.2. They're going to want us to find, let's change that color to a green. Let's find E prime, F prime. So that's our unknown. So let's find that. So how will we do it? We basically will set it up like this. I'll say 9.1, that's my A, B, divided by, again, which one corresponds to that would be A prime, B prime, 10.5. It should equal to, going back to our first shape, which is 5.2, divided by my unknown, which is X. That should be equal. That's proportional. So all we're going to do here, guys, is solve for our X value. And let's write it down how that will look when we solve for X. And so in this case, X will equal to, now watch how I'm writing this, 5.2 times 10.5 divided by 9.1. So that's what we'll be looking at for our X value. And then when we do that, it should give us the proportional of what we need. So once we do the math, and notice this is 10.5. If you do the math correctly, multiply the numerator and then divide by 9.1, we should get about like 6.0. And since we're talking about centimeters, I'll leave that as my answer, 6.1 or 6.0 centimeters. So that will be our E prime F prime, 6.0 centimeters. So that's what we're looking at. Now let's look at this obstruction lies between point A and B as shown in this figure below. So this is another example. We have the distance you see here from A to E, E to D, B to E, E to C. As you look at that diagram, and there's marked below. Now what we want to determine what is the distance between A and B. Okay. So let's go on our whiteboard, draw this, and maybe you want to try this before I show you the answer, show you how to do it to see if you get the same answer we get for this particular problem. So here's our figure on the whiteboard. And these are our numbers, and what's in red and what we want to find is our X, the length from here to here. Now first we've got to see how are there similar figures. Again, they're similar figures. One of the things I've noticed is that we have something called a vertical, and I'm going to vertical angle. So this angle is equal to that angle. That's corresponding to that angle. Okay. Now knowing that, it looks like that we have a side, and I'm going to write this and delete. We see that we have 12 and 10 here, 12 being a greater number, 10 being the lesser number. So in this case, it looks like that the 10 will correspond to the 25 and the 12 will correspond to the 30, which is the greater number on the bigger triangle. This 15 will correspond to that X. So I'm going to delete all that so you can see going back to what we have here. Again, using the vertical angles, knowing that this angle is equal to that angle, we know the relationship we have right now is we have 10 over 25 is equal to 12 over 30, which they are. Proportionally, they are equal to each other as we do our calculations here. And so that means this is equal to, again, I'm using a smaller one. We're saying 15 over X. Now, let me rewrite that. So notice our bottom down here is 25, 30, and our X. And that's our bigger triangle. And the top has our smaller, okay? So let's actually solve this since it's proportional. Since they're proportional, we can solve this. So what we're saying here is X over which value we're going to use is 15 is equal, in our case, since I use a bigger triangle first, I'm going to say 25, I'm going to use the bottom, divided by which number we're going to use for the bottom in this case, which would be 10. So to solve for X will equal to 25 times 15. Divide that by 10. So that gives me 37.5, whatever units we're talking about, which I believe was meters. And so forth. Therefore, that is our value for X using similar triangles. Again, I hope that helped. And if you have any questions, look over the videos again. And then also look at some of our supplementary material we have on our MathLink website. Again, let math bring it together, or MathLink bring it together. Thank you again for watching this video.